Sylvester METU denen şeyden bahsedeceğim. Extraction for function local privileges. For example, ordinary differential equation course, we have computed probably exponential of a matrix, right? That we have operators, and you just run into the power series and you compute it using either its regular form or canonical form. What we are going to do, we will consider again operators and their functions, but not necessarily the exponential function, arbitrary functions, but actually not that arbitrary. We will consider analytic functions, and then we will try to compute analytic function of that operator. So in this section, learn how to compute right? A is an operator, and f of x is an function. As I said, you have already seen this actually agent when f of x is the exponential function, right? In differential equation form. Okay, now how we will do this? Well, I will give two definitions of f of a. So what does this mean? F of a. You will see two definitions, and then we will see that actually they are basically the same definition. They agree. Okay, now given a function f of x, not necessarily analytic function in this case, and a diagonalizing operator. A from B to B, f of A is defined by the following formula. Now, since A is diagonalizable, right, there is a basis consisting of eigenvectors of A. So these are eigenvectors, namely A of EI is just lambda I times EI. And in this case, note that we can write our operator using tensor notation as follows. So this operator sends the eigenvector EI to lambda I times I. Therefore, I can write our operator as follows. It's a symmetric from 1 to, and let's say, supporting that here is the dimension of D Okay, so our operator is the following. Lambda I times EI star. EI star is the dual element. So when you feed this guy with EI, this will give you 1. Therefore, the result will be just lambda I times EI. Değil mi? Yani A'nın içine EI'yi koyarsanız EI'yi diyecek ve 1 diyecek. Dolayısıyla cevabı 1 çarpı lambda çarpı EI yani lambda çarpı EI alır. So, for this operator, we define f of k as follows. So this is the definition. What we do is the following. We just put this lambda inside f and then EI and then EI. Yani f'in A'daki değeri bir başka operatör. So f of A is also a linear operator, right? It's a linear operator. It maps, so f of A of EJ is what? When you plug EJ here, EI times EI star of EJ, so this is just, okay, so let me run here, summation over I, equal lambda I, EI, and then EI star in J. So this digit evaluated for this, but this thing is just lambda I, EI star for EJ. This thing is just perimeter delta ij, right? Perimeter delta ij. So it is 1 if I and j are the same, otherwise it's 0. Therefore, f of A of ej is equal to what?
Kamerayı çek.
Summation from 1 to 10, f of I, and then I have to put delta ij. This means this is 0 if I is different than j. It is 1 if I and j are the same. So all these terms are 0 except I equals j, and then I equals j, we have just j here and then each. So the jth element is just mapped to jth element times f of lambda j. In particular, if A is diagonalizable, then f of A is also diagonalizable, right? With the same basis of eigenvectors, right? Because this is just mapped to some multiple of the element. This is true for all j, of course, for all j. Therefore, this operator is also diagonalizable, but this time the eigenvalues are just these numbers. So, in particular, f of A is also diagonalizable. With the same set of eigenvectors, and eigenvalues, so let's show you so that f of A of E J is just f of lambda j is. So if all operators were diagonalizable, then I would stop here because we just define what is f of a and how we compute it, and we are so the lecture would finish here. But we know that not all operators are diagonalized. Okay, therefore this definition only works for diagonalizing operators. What we will do in the rest of the lecture, we will see how one can define f of a in case a is not diagonalizing. So the question is, what if a is not diagonalized? Her maddesi diagonalizing söyleyeceğiz. Hayat çok kolay ve şey olurdu. Interesting olmazdı yani, sıkıcı olurdu. Bitmişti ders şu an. Okay. Okay, here is the second definition. Okay, now for generally operators, we will do another definition in the case f of x is a full function. What do we mean by analytic function? We mean the function f of x has a yes, infinite power series extension. It will be, of course, Taylor extension. So a n times x to the power with some radius of convergence, with a positive radius of convergence. O zaman şunu yapabilirim. Genel bir f için yapamıyoruz bunu. Çünkü her fonksiyonun power series extension yok. O zaman da a'yı nereye koyacağımızı bilmiyoruz. Ama böyle bir ifade varsa a'yı nereye koyacağımız belli değil mi? X yerine a verir. So in this case, as here's the definition. I'll just write here a to the power. Okay. I can just compute all a to the power and add them up. Of course, there is this problem that is this thing meaningful? So is this thing convergent? Provided that is convergent. And this power series is convergent. The power series. Of course, convergence of this is a problem of calculus, advanced calculus, not linear algebra. So we will not think about this much, but I'll tell you a few things about it. But we need to, real analysis course, basically. The observation is the following. Here, okay. I said this is the definition for a general operator. Here, A doesn't need to be a diagonalizable operator. However, if A is diagonalizable, then we have two definitions for f of A. One definition is this one, right? One definition is this, and this is the second definition, right? So we need to show the following: if A is diagonalizable, these two definitions are the same. Otherwise, it doesn't make sense. And you define something, but depending on definition, you get different results. That's not acceptable. So we have to prove that these two definitions agree when A is diagonalizable. So what's so the definitions must agree okay. Well, let's see that. So, let's do that. Is diagonalizable. And third one is the basis of eigenvectors consisting of yani ne demek? A of I is lambda I times C I. Here lambda I times some states and this is group of I. Okay. Now we have to show that the two definitions are the same. According to the first definition, second definition, our operator is defined to be like this. Okay. Well, this is from 0 up to infinite. I have to show that this gadget on any vector, right, is the same as this gadget. What was the first definition? It was I from 1 to n, f of lambda I, e I, e j star, there. E I star, e I star, elevated for all B. So this is the problem. This is the question. For all B. Yeah, bunu göstermek istersin. Okay. Well, it is enough to prove this, not for all vectors. It is enough to prove this only for basic vectors, right? If both sides agree on every basis vector, then the two sides are equal. It is enough to show this on the board for E equals E up to J and I have it. Because if two operators agree on a basis, then they are the same. So it is enough to check this only for the basis vectors. Okay, and I have a basis for the symbol eigenvectors. All right. So let's start with the left hand side. And in the power. And evaluate this from EJ. Well, what is this? And minus EJ. But what is this digit? Well, EJ. So this will be just lambda J. So lambda J will go out, but then we have A times EJ. That will be another lambda J. So this is just lambda J plus EJ. Right? And so on. Therefore, if you just apply this n times, then you just get lambda J to the power n times EJ. Therefore, this will be just equal n lambda J to the power n and then EJ. Okay. Well, you see, here's this vector is independent of n, therefore I can just write it this way. This is just this number times the vector EJ. But what is this number? This number is just f of lambda j, right? F of x is this energy function, n to the power, n times x to the power n. Therefore, then plug lambda j here, you just get n times lambda j to the power n, and then we have summation from 1 to infinity. Therefore, this thing is just f of lambda j times EJ. But what is this? What is this digit? I have done that computation over here. So f of lambda j times EJ is just f of a times EJ. This f of a is the first definition. The f of a is the first definition. So this thing is just equal to what? That gives it over there. We have 1 and f of lambda pi. Cancel E I star applied to EJ. So what we have seen is that this operator on any basis vector is equal to this operator on that basis vector. Therefore, the two definitions are the same, provided that A is diagonalizable and F is an analytic function. If it is not analytic, of course, you don't have the second definition, because we are using the analytic extension of F to define F of A. Tamam mı?
Bunun ne olduğunu söylemesi gerekiyor mu? Tamam.
Aslında gerekiyor ama ya çok zor. Tabii burada efendim
Sonsuzluk diyorsun. Tamam, çıkarttım onu.
yok çıkmıyor. Tabii sorusuna hiç bakmadım. Convergence sorusuna. Burada hani nerede çıkıyor convergence olayı? So here one has to be of course careful. I have this infinite sum here. Now this is the number, real or complex. When we are dealing with analytic functions, you may work with real or complex numbers, doesn't matter. So the same theory works. And in this case, there's this problem that whether this thing is well defined, is this thing convergent? For this thing to be convergent, of course, we have to have what? This number J, it has to be more less than the radius of convergence. So if your eigenvalues have norm, they can be complex numbers. If the norm of each eigenvalue is less than your radius of convergence, then this summation is convergent. So this is a number, and you can then just show that this is a linear operator. But so you have to have this. Okay, so it's a byproduct of this computation that this thing is well defined, provided that your eigenvalues are less than the radius of convergence of the power series. Yes.
Hocam mesela o zaman şey olsa, analitik olsa, işte operatörde diagonalizable olmazsa, onu nasıl yapıyor mesela, onu göstereyim.
Evet.
Radius of convergence nasıl olacak yani? Hani A sonuçta hani normu olan şey olan falan bir şey değil ya, bir matris sonuçta.
Normu var, onu da göreceğiz. A'yı vektör olarak yazabilirsiniz, değil mi? Yani biz A nedir? Bir dikdörtgen içinde sayılar var. Onu tek bir vektör gibi yazın, alın. Kolonları yan yana, romları yan yana olacak. Bu vektör olacak, onun normu var.
Ama o matris olmadı.
Efendim?
Aynı matris olmadı ama.
Matris olarak da yazılır. Yani bu sadece şey, hani Aren'deki vektörün normu nedir deyince aklınıza bir şey geliyor da matrisin normu deyince gelmiyor ama matrisi de bir vektör gibi düşünebilirsiniz. Bütün entelerin karelerin toplamı. Bunun kare.
Hocam yine orasını anladım da yani şeyi gösterecek misiniz çok merak ediyorum. Bu herhangi bir operatör için analitik fonksiyon için anlattığımızda bu converge eder neye göre?
Vallahi bilmiyorum ne kadar göstereceğim çünkü dediğim gibi lineer algebra dersi olduğu için analitik tarafları Turgut'un dersine bırakıyorum. Ya da 349'a. But here, so for this to be convergent, we have to have the eigenvalue must have radius of convergence must have norm less than radius of convergence. So in differential equation first, you had f of x equals, right? This was the exponential function. And radius of convergence of that operator is infinite. Therefore, everything is converged. Okay? In that course, you didn't care about convergence because the radius of convergence was infinite. Okay. Senin soruna cevap vereceğim bilmiyorum. Göreceğiz. Yani yazarın böyle bir derdi yok da. Bence bir işin cevabını. Muhtemelen yine aynı şey geçerli tabii yani. Diagonalizable olmasa da eigen değerler var. Repeat olabilir. Aynı şey geçerli. Eigen değerler şeyden küçükse radius of convergence'dan convergent olacaktır. Okay. Tabii bunlar aslında bu power seri şeyleri falan reel veya kompleks fieldler dışında da yapabiliriz. Yani işte Mann teoremi vesaire öyle de yapılıyor. Orada da işte norm vesaire introdüse ederek yapılabilir. Okay. Şimdi şey de söyleyeyim. Derivatif. Form tarihçiyiz. Is defined. Yes. Sure, the of and then here I have 10 times. That's the definition, but actually analysis, you can show that, you know, if this is a function, of course, we know how to take its derivative, and what we are claiming that the derivative of this function is this power series. So this is actually not a definition, but a theorem, but it's a theorem in real analysis. Okay. This is the yani uniform convergence. İspatı siz gördünüz mü bunu hiç bir yerde?
Biraz.
Uniform convergence. Evet.
Hocam şey değil mi? Atıyorum AN serisi AN eksi AN işte ondan küçük olmaya başlıyor. Ben öyle gördüm.
Neyse, yani serilerin kronolojisi de bir şey ama bu da işte illa sayıların serisi değil de fonksiyonlar serisi vesaireler. Ee, Onlar girmeyeceğim. 349 dersinde hani bunlar yapılıyor. Veya işte değerlendirmesi. Ve hani orada ispat ettiğimiz şey şu. Bir fonksiyon olarak alıp da alırsanız bunun türevi var. Türevi de bir başka power serisi. Devre. Okey. Şimdi kompetitif isteyelim. Burada da şeyimiz Sylvester method olacak. So this is a method. Is a power series is an analytic function. Analytic function lafını duyduk daha önce. It's a function given by a power series. Okay? Analytic function. And okay. Diagonalizable, sir. When is diagonalizable? We have seen how we computed. It is easy, but of course the main concern is when this operator is not diagonalizable. So there's some easy cases. Let's see some examples. Suppose A is an operator. So that N square yani neydi bu? Projection değil mi? Bakın projections'da bu hesap nasıl yapılır? Okay. Well, if there is a projection, then of course N squared is just N squared times A, but N squared is just A, so this is A times A, but this is A squared, so it's still A. Therefore, what we see is that similarly, A to the power n is always a. Okay. So, what is f of a then? According to our definition, this was I mean, of course, so let me say, suppose f of x is a function. It's power 10. And R is the radius of convergence, which is a positive number. Then what is f of a? F of a is just a n times a to the power n. But a to the power n is just a. Therefore, this is just a. So you see, this thing is just independent. There is no and here, so I can just write it this way. And what is this? This is just okay. So f of a is just this thing, but I can write it this way. And then here I have 1 to the power and then a here. So what is this then? This is of course just f of 1 times a. So f of a is just f of 1 times a. Of course, for this to be meaningful, this thing should be defined, and it is defined if r is bigger than 1. So this is meaningful. If the radius of convergence is greater than 1. Ya da bir radius of convergence'dan küçükse. Dolayısıyla eğer, so if our operator is a projection, then f of a is just f of 1 times f of 1 times a. Tabii operatörümüz çok özel bir model. Değil mi? So, for example, as a specific example, let f of x with cosine x. What is cosine x? It is the power series. X to the power. So it is 1 over n factorial and maybe 2 n. 2 n factorial x to the power 2.
Eksi virüs n.
Evet, öyle bir şey vardı. Şöyle, ya da eklersek daha doğru, değil mi? Radius of convergence neydi? Radius of convergence is infinite, right? Cosine is defined for all the numbers. And if it is a projection, if is a projection, then f of a will be just, so it is cosine a, and what is cosine a? It is, of course, if it is larger than 1, so it will be just cosine 1 times cosine 1 times. So it is basically just a mark model. Mark model. Okay. Peki. Pardon, şurada biraz dikkatli olmamız lazım. A'nın sıfırıncı kuvveti A değil. A'nın sıfırıncı kuvveti A'dan gitti. And this so, so one is to be careful here. So we can just correct this. Evet, burada da aslında onu yapmam lazım. So let's take out the zero term. So this is a zero times identity plus from 1 to 50 and 85 and that is just a zero times identity plus this is just a n times 8. So this is just a zero times identity plus. Now, what is this given? That is not f of 1 because you know f of 1 is like what is f of 1? F of 1 is n x to the power n. So this is just a zero times summation. So summation from 1 to infinity f of n is not f of n, but f of f of 1 minus a 0. So this is just so this thing here is just f of 1 minus a 0. And then I have 1 here. So what we have is that A sıfır parantezinde yani şöyle yazabiliriz. Tamam, bunu böyle yazayım. Burada ne olacak? So here we will have cosine A. It will be just A0 is just identity, right? So for cosine x şöyle yazayım. A0 identity plus f of 1 minus A0 times A. Therefore, f of A is just A0 here, the coefficient value equals 0. When you plug in equals 0, you get 1 over 0 factorial, which is just 1. So A0 is just 1. Therefore, it is just 1 plus f of 1 is cosine 1. Cosine 1 minus A0, which is 1 times A. Okay. Yani kosinüs birden bir çıkartıp sonra ayrılacak. Okay. So let's have a break. After the break, we'll continue.